I'm Brandon Ponder. I'm an undergrad in aerospace engineering at the University of Michigan. This summer I've been doing research under Professor Mark Moldwin and Ari Schenker. He's a postdoc in electrical engineering from Israel. So we've been working this summer to explore the usefulness of smartphone sensors, specifically the magnetic sensors, on future CubeSat missions. So before I talk more about that though, I want to go show you my lab, so let's go. This is a Honeywell HMAR 2300 magnetometer. I'm just setting it up. Right now, what it's going to do is it's going to measure the signal given from this coil, and it's going to send that data to the computer for me to later analyze that. So now that I've finished setting that up, I wanted to go back and explain to you where this comes in. So this magnetometer, this is not a smartphone magnetometer. This magnetometer, we use this as a reference for these smartphones. So this is a Galaxy S4, this is an iPhone 5S. So these have magnetic sensors inside, and these are the ones we've been really analyzing all summer long. So we've tested these in a couple different locations to measure the accuracy and the sensitivity mainly. We've measured a couple other things, but in order to do that, we've stuck them outside. We took this magnetometer and we stuck it outside. You can think of it as like a thermometer. You can think of this as a really advanced thermometer. And let's say we go outside and the temperature is 77. And this says it is exactly 77.2 degrees Fahrenheit. So now we go outside with this and we throw it out there, and it says, in a magnetic field type of standpoint, this says that it's 81 degrees. Okay, so then we record that difference, and we can see that this it gets the right idea, but it's not very accurate. Now we go outside and then we stick this one out there, and this one says, instead of 77, this says it's 75. Okay, so that's kind of what testing we did for accuracy. We use this as a reference, and now we're not doing these for temperatures, we're doing these for magnetic field readings. So, in Ann Arbor, Michigan, the magnetic field's about 54,000 nanotesla where we're at. So, these will measure different values, and we found that they get the right idea, but they're not too accurate. But we've analyzed that nonetheless. So, for sensitivity testing, what we did was, what we would do is we'd find the standard deviations of this, and we would stick these phones in here, and we'd stick them in this. This is a magnetic shield. It blocks external magnetic fields from, so basically anything that goes in there, it's not exposed to the magnetic fields like in this room or from the Earth as much. So if we were to just stick this in here, run a little app that we developed, and that reads the magnetic field, it takes it from each of the axes. So we stick it in there, and it would read pretty close to 0 on each of the axes. And then we would take that data, we'd send it to the computer to analyze the standard deviations and other stuff, just to figure out just how sensitive it is. Do the same thing for the iPhone. So that's most of our accuracy, sensitivity testing. We've done other testing, but those are our biggest ones. Now, how this all relates to usefulness on a CubeSat mission, well, we want to analyze these. We kind of want to make our own data sheet, per se. We just want to see in their space conditions how well they're going to perform. Well, so what we've been looking at is a lot of these other magnetometers, they're more advanced. They have precision down to 1 nanotesla value, so they can read small deviations in magnetic fields for geomagnetic storms or other space weather phenomena. But these things, they measure on the micro Tesla, so it's a 3 orders of magnitude difference. So these are a lot less sensitive, so we can't measure we can't measure such precise small changing phenomena like that. But rather, so what I've been exploring is what kind of thing, how can we put these on a CubeSat, maybe in some sort of formation out in space, to to measure something. So that's most of what we've been doing with these smartphones. So that's a small summary of the work that I've been doing this summer. I love this experience. I loved working in this lab. I want to thank the Summer Undergraduate Research Experience Program for giving me this opportunity, and Professor Moldwin for choosing me to work with his team. So yeah, hopefully a lot of what I said made at least a little bit of sense to you guys. That's about it.